Liz, just talk about lutein to start off with, and talk about why that is so important and what it is.
Okay, so lutein is a carotenoid. Carotenoids are plant pigments. So
Okay.
when you think about this time of the year, when the leaves are turning orange and red and yellow, those are all carotenoids. And in
Okay.
nature, there are hundreds of carotenoids. But in our diet, there may be 50. So think about tomatoes and carrots and winter squash. They have color, and that color is due to these plant pigments, these carotenoids. The thing that makes lutein interesting, that even though we have hundreds of carotenoids in nature, we eat maybe 50, about 20 or 30 actually end up in the body, in the blood, in the tissues. Only 2 carotenoids get into the eye. And that's pretty amazing when you think about going from hundreds to 50 in the diet to 20 or so in the body, but 2 in the eye. And what makes it more astounding is that these 2 carotenoids, called lutein, which you mentioned, and zeaxanthin, which is very similar to lutein as far as the molecule, how it looks, they're very much alike. These are the only 2 that end up in the eye, but where they really need to be. So they get into the lens to the exclusion of other carotenoids, and they get into the part of the retina called the macula. Now the macula is a part of the retina that's centrally located. So I'm looking at you right now through my macula. So it's this tiny piece of the retina that's centrally located that's responsible for acute central vision. But because it's centrally located, with decades of light exposure, that's the part of the retina that's particularly vulnerable to light damage. So that's the part of the retina with age tends to deteriorate. So then we have this disease called age-related macular degeneration, which is the macula degenerating. And that part of the retina is where you find lutein and zeaxanthin. And you find them there in concentrations 500 to 1,000 times more than anywhere in the body. So here we have these 2 pigments that are known to be antioxidants. So think of light. Light is damaging. It causes oxidative damage. Here we have 2 pigments that are antioxidants that are concentrated in the part of the retina that gets oxidative damage. So that's terrific. That's terrific. So that's why we think they're important, because they're located where they need to be to prevent damage. Now in the macula, they're referred to as macular pigment. And this macular pigment is placed in front of your photoreceptor cells. So you have this yellow pigment, the light coming in, and it blocks that light from going on to damage those photoreceptors. So that's why we think it's important, both as an antioxidant and as a blue light filter.
You talked about it being a carotenoid. Can you describe what those are real quick?
Sure. I mean, the common ones that people may be more familiar with are beta-carotene. Beta-carotene, people talk a lot about beta-carotene because 1, it's a major carotenoid in our diet, and 2, among all the carotenoids, it has the highest pro-vitamin A activity. It actually turns into vitamin A, which is essential. We need vitamin A every day. But not all the carotenoids do that. Lutein doesn't do that. Lycopene, another carotenoid that we find in tomatoes, that does not turn into vitamin A. So those are the 2 more common carotenoids that we talk about, beta-carotene and lycopene. And they too have their own roles in health. Beta-carotene as a vitamin A source, and it's an antioxidant. And lycopene is thought to be important for decreased risk of prostate cancer and through its antioxidant properties.